we're going to be making our review video or watching our review video for section 10.1. That's chapter 10, section 1. And the learning target for today is to determine whether a function is linear or nonlinear. Well, we've got a new term there, nonlinear. Nonlinear function is a function that does not have a constant rate of change. A graph of a nonlinear function is not a straight line. So a linear function is one that does have a constant rate of change and is a straight line when it's graphed. So let's look at the first problem here. Determine whether the table represents a linear or nonlinear function. Well, the changes in x, that's a change of 2. The changes here, change of 2. Change of 2, so the change in the x values is constant at 2. The change in here is 18. The change from here to here is 34. The change from here is 50. So this is a non-linear function because the rate of change would be 18 over 2 for the first one, 2 over 34 for the second. Those are not, I'm sorry, I wrote this second one wrong. 34 over 2. And those two fractions or rates of change are not the same, so this is a non-linear function. Determine whether the table represents a linear or nonlinear function. Explain. All right. Well, the change from right there is 2 units. The change right here is 2 units. The change right here, 2 units. The change in the y is 4. The change in the y here is 4. The change in the y is 4. So 4 over 2 would be my rate of change, or 2 is a constant rate of change, so it is linear, and the rate of change is constant, so it's letter B. Determine whether the table represents a linear or nonlinear function. Well, as I look across here, x goes up by 3, x goes up by 3, x goes up by 3, so it's looking possible. X goes up by 9, or sorry, y goes up by 9, y goes up by 9, y goes up by 9, so my rate of change here would be 9 over 3, or simply 3, and it is constant, so this is a linear function. It would be graphed as a straight line, so it is a linear function. Determine whether the table represents a linear or nonlinear function. Well, as I look at my x values, x changes by 2, x changes by 2, x changes by 2, so that checks out. Here, x changes by 5, x changes by 6, and x changes by 8. So this is a non-linear function because the rate of change is not constant. So letter C is my answer. Determine whether the graph represents a linear or nonlinear function. I would refer you back to our definition. Our definition says if it is a linear function, it would be a straight line. Obviously, this is not a straight line, so this must be a non-linear function. Number 8, determine whether the table represents a linear or nonlinear function. Actually, this is a graph. I can look at it right away. As I see right away, it is a curved line. Since it's a curved line, it is a nonlinear function. Nonlinear function. Determine whether the graph represents a linear or nonlinear function. Straight line must be linear. So this is a linear function, and it can be written in the y equals mx plus b form. Y equals mx plus b form. Looking at this equation, determine whether the table represents linear or nonlinear. It's a straight line, so it's linear, and it can be written in y equals mx plus b form. Determine whether the equation or the function y is equal to 5x squared plus 5 represents linear or nonlinear. Y equals 5x squared plus 3. Since it's x squared, since it's to a power that's greater than 1, it must be nonlinear. If I were to graph this, this would not come out to be a straight line. It would be curved. It could not be written in the y equals mx plus b form, so it is nonlinear. Looking at this one, determine whether y is equal to x squared minus 1 represents linear or nonlinear. I look at the power of x. Since it's to the second power, it must be nonlinear, and it cannot be written in the y equals mx plus b form. Determine whether y minus 4 equals 5x represents linear or nonlinear. Well, I'm going to write it in the y equals mx plus b form by adding 4 to both sides. These cancel out. Y is equal to 5x plus 4. So that is in the y equals mx plus b form, where the slope is 5, and the y-intercept is 4. So yes, this is a linear function. It is a linear function. Determine whether negative 3x is equal to y plus 6 represents linear or nonlinear. Negative 3x equals y plus 6. I'm going to subtract 6 from both sides. So negative 3x minus 6 is equal to y, because these cancel out. Or I could shift it around and say y is equal to a negative 3x minus 6. So this is in the y equals mx plus b. It's a negative 3 slope and a negative 6 for my y-intercept. So it is in a linear, or y equals mx plus b form, so it is a linear equation. It is a linear equation. Clocks. Use the table below to determine whether or not the number of revolutions per hour that the second hand on the clock makes is a linear function of the number of hours that passed. Well, you can see the change here, 1 hour, change here, 1 hour, change 1 hour, change 1 hour. So that meets our requirement. The change here is 60, the change here is 60, change here is 60. Looks like the change is constant. Since the change is constant, it is linear. It is a linear function. Okay. Geometry. Use the table below to determine whether or not the sum of the measures of the angles of a polygon is linear. Function of the number of sides. Well, if I look at the number of sides, went up by 1, went up by 1, went up by 1, went up by 1. So that meets our requirement. This, the change was 180. Here the change was 180. Here the change was 180. And here the change was 180. So the rate of change is constant. The rate of the change is equal throughout all of those. So this is a linear function. Answer A is our correct answer.